Dear students, my greetings and my happiness to meet you today. Me, Mr. Abdalnasser Jabir, and my colleagues in Studio 12 in Educational TV 1. Today, inshallah, we are going to study a new lesson in trigonometric lesson, which is the trig functions. Trig functions, we have studied some about them the last year, and now we will continue our studying. What is the trig functions? We will have trig functions in right angled triangle. Let's concentrate here. We have a right angled triangle here. Right angled triangle. A, B, and C, and B is right angle. From our previous studying, we know that if you concern about the angle C, then we study the first function, which is sine C. Sine C here is the opposite over hypotenuse. Opposite over hypotenuse, which is AB over AC. The same angle C, we can write cosine the angle C. Cosine angle C equals adjacent side over hypotenuse side. Adjacent over hypotenuse, which is A over H, which is CB over AC. And we know about tan C. Tan C here is the opposite over adjacent. So it's AB over CB. Some of you can say, what is the opposite, what is the adjacent, and what is the hypotenuse? If we have an angle C, then the opposite side to it, we call it opposite side. And the adjacent is the side beside the angle C. And the hypotenuse is the opposite side to right angle. So we have C, its opposite is AB, its adjacent side is CB, and the hypotenuse side is AC. And if we concern with the angle A, we can say that sine A equals what? Of course, it's equal the opposite of A, which is CB, over the hypotenuse, which is CA. And if we concern about angle A, we can say cosine the angle A. Cosine the angle A equals adjacent of it, which is AB, and of course over hypotenuse, which is AC. And tan the angle A, it will be the opposite of it, which is CB, and its adjacent, which is AB. So we can say that the trig, which we studied before in third preparatory, the angle C, we can say sine, cosine, and tan. And for angle A, we can say sine, cosine, and tan. And if we concentrate, here tan C equal sine C over cosine C. We can prove it. We have sine C here, AB over AC, divided by or over cosine C, which is CB over AC. Of course, here it's equal AB, which is AB, over CB, because divide will return to multiply, and the reciprocal of AC over CB, and we can deduce that AB over AC is the remainder, and AC cancelled with AC. Okay, let's now decide about something else, which is unit circle. What is a unit circle? Unit circle. If we have x-axis and y-axis, as we see or draw here, this is the y-axis, this is the x-axis, x dash, y dash, and here is O, which is the origin point. Origin point is the point 0 and 0, and it is the intersection point between x-axis and y-axis. And if we have a compass here to draw a circle, but we have a very important condition for this circle, that the radius here equal 1. What 1? 1 centimeter, 1 meter, 1 kilometer. It's finally we call it 1. And we draw the circle here like that. Let me clarify it for you. We have a unit circle. We call unit circle. That means that OX here is 1. 1 centimeter, 1 meter, 1 kilometer, it's 1 finally. And of course, here we can say OA. If we call it here B, OB will be also 1, and OC equals 1, and OD equals 1 also. So it is unit circle. Unit circle, its radius equal 1 or equal the unit. Okay, and if we have here a point, say it's E, okay, and we will complete the right angle triangle here, perpendicular from A to the x-axis here. So we have here right angle, and we will join OE. So we have right angle triangle OEL as example. The triangle OEL here is right angle triangle, and some of you intelligent students can tell me easily what the length of OE. Yes, it's 1 unit also, because OE is the radius of the circle, equal OA, OB, OC, OD, and so on. So OE here is the unit. Right angle triangle ELY. Let's call this part, which is OL, X. We call it X. And let's call EL is Y. Okay, so we have two sides. The side OL is of length X, and the side AL is Y. Okay, and let's call this angle is theta. Okay, let's angle, this angle is theta angle, and we'll try to find the trig functions for the angle theta here. So let's say sine theta, cosine theta, and tan theta. What is the sine theta? We know sine of the angle theta here is opposite, which is y, over hypotenuse, which is 1. So sine theta equals 1, y. And cosine theta equals the adjacent, which is x, over hypotenuse also, which is 1. So cosine theta equals x. Tan theta is the opposite, which is y, over adjacent, which is x. So tan theta equals y over x. We know that y is sine theta, and x it is cosine theta, and this is another proof that tan theta equals sine theta over cosine theta. Okay, so when we deal with the unit circle, we know that the hypotenuse equal 1, and so that sine theta here is y and cosine theta is x. And don't forget that this point is of coordinates x and y. So here all the time of the unit circle, x is cosine theta and y is sine theta. What is theta? Theta is the angle EOA. Okay, let's move to another thing about the interval of x. X here on the circle, starting from this point to this point, from C to A. This part is 1, but we have here -1, and we have here 1. So x belongs to the closed interval -1 and 1. And what is y? Y move from here, which is -1, to here, which is 1. So y also belongs to the closed interval -1 and 1. Okay, and we will deduce that if we will find sine power 2 theta plus cosine power 2 theta. Sine power 2 theta equals y power 2, and cosine power 2 theta equal x power 2. And we know that y power 2 plus x power 2 equals 1. So we can deduce also that sine power 2 theta plus cosine power 2 theta equals 1. Why they are equal 1? Because we have here right angle triangle ELO, right angled at L, and if we want to applicate Pythagoras theorem, which is EO power 2, which is hypotenuse power 2, of course equals y power 2 plus x power 2. So x power 2 plus y power 2 equals 1 power 2 here, x power 2 plus y power 2 equals 1 power 2, which is equal 1. So from the unit circle, which is OE, make it as a 1 unit in the right angle triangle ELO, and we will applicate Pythagoras theorem here. So y power 2 plus x power 2 equals EO power 2, which is 1. So x power 2 plus y power 2 equals 1. What's x power 2? It's cosine power 2. What is y power 2? It's sine power 2. So we deduce now that sine power 2 theta plus cosine power 2 theta equals 1. Okay, let's move about something else, about the trig functions and its reciprocals. What is the reciprocal? We know about reciprocal that if we have here as example 2/3, its reciprocal will be 3/2. So if we have sine x equals as we said before, that sine x equals AB over AC in the right angle triangle here, ABC, and let's call this angle is x. So sine x is AB over AC, opposite over hypotenuse. And its reciprocal will be 1 over sine x. And we call it cosec x. Cosec x here equals 1 over sine, the reciprocal of sine function. And of course, it's equal AC over AB. So, sec or cosec, the function x, it's the reciprocal of sine, and the numerator will be denominator, and vice versa. So, it equals AC over AB, which is hypotenuse over opposite. Okay? We know that sine in angle equal OH, which is opposite over hypotenuse, but cosec, we can call it CSC. Cosec x will be H, which is hypotenuse over opposite. So now we have cosec function, we can call it CSC. Okay, let's move to the reciprocal of cosine. We have here cosine the angle x. Cosine angle x equal adjacent over hypotenuse, which is CB over CA. And we have its reciprocal, which is sec. Sec x is the reciprocal of cosine x. So it's equal CA here over CB. And cosine x, we know that equal adjacent over hypotenuse. So its reciprocal, which is sec, equals hypotenuse over adjacent. What is the reciprocal of tan? Tan is a function. The reciprocal of the tan function, if we can say tan x here is the opposite over adjacent. So it's AB over CB. Okay. The reciprocal of tan x is, we call it cotan, but we write it COT also. Cotan x, it is the reciprocal of tan, so it equals CB over AB. And of course, cotan x equal adjacent over opposite, because here tan x equal opposite over adjacent. Okay, so let's move to some examples here. We have examples to applicate the exercises on unit circle. So let's concentrate about the following example. If we have unit circle here, like that, and we have the origin point here, this is x-axis, and this is y-axis, and there is a point which is A, and this point is, its coordinate is 3 over 5 and 4 over 5. This is the coordinates of the point E as example. Okay, so we can complete the drawing. We can join OE here and draw perpendicular to the x-axis here, and of course x will be 3 over 5 and y will be 4 over 5. Okay, and let's call this angle is theta. So sine theta equal opposite over hypotenuse, which is 1. Okay, so it's 4 over 5. Cosine theta is the adjacent over hypotenuse, which is 3 over 5 over 1. So it's 3 over 5. And tan theta equal opposite over adjacent equals 4 over 5 divided by 3 over 5 equals 4 over 5 multiplied by 5 over 3. Cancel 5 with 5. So it's 4 over 3. So sine theta here is this part, and sine theta is this part, which is y. This is sine, and cosine is this part, which is cosine, and tan is 4 over 3. Let's go to the reciprocals of sine, cosine, and tan. We can say that sine theta, its reciprocal is cosec theta. Cosec theta is the reciprocal of sine, so it's 5 over 4. We can make reciprocal here. 5 will be numerator and 4 will be denominator, so it's 5 over 4. The reciprocal of cosine theta is sec. Keep with me, my dear students. Sec theta equals 5 over 3. The reciprocal of tan theta here will be cotan theta, and it will be 3 over 4. Okay, so we have a point on the unit circle, this point called E as example, and it is 3 over 5 and 4 over 5. We can from this point find the trig functions. This is cosine theta, and the second coordinate is sine theta, and sec theta is the reciprocal of cosine, will be 5 over 3. Cosec theta is the reciprocal of sine, so it's 5 over 4. And tan theta will be sine over cosine, so 4 over 5 divided by 3 over 5. Let's move to another example. If we have a point as negative 1 and 0, if we have a point E is negative 1 and 0, where the point E, which is negative 1 and 0, it's a unit on the, is a point in the unit circle. And the request is to find the trig functions of this point. We know that this part will be x, and x is cosine theta. So cosine theta equals negative 1. And we know that the second coordinate is y, which is sine theta. So sine theta equals 0. And we know about tan. Tan theta here is sine theta, which is 0, over cosine theta, which is negative 1. So it's 0. And let's move to the reciprocals of these functions. We know that the reciprocal of cosine is sec. Sec theta. We know negative 1 means negative 1 over 1. So it will be 1 over negative 1. So it's negative 1 also. Reciprocal of sine theta, it will be cosec theta. Cosec theta, we know that sine 0 over 1. So cosec theta equal 1 over 0, which is undefined. If we have a number over 0, my dear students, we call it undefined number. So here it is undefined. What about tan? The reciprocal of tan is cotan theta, and cotan theta is the reciprocal of 0 over negative 1. So it's negative 1 over 0, and also is undefined. Okay. Let's move to another point. If we have another point as a point E, which is negative half and y, and we have a condition here that y greater than 0, well, that means that y here is positive, and we have to find the value of y here. But we know that if we have a unit circle and we have a point on it, so as example negative half and y, we know that x power 2 and y power 2, x power 2 plus y power 2 equals 1. This is the rule which we studied before. X power 2 is negative half power 2 plus y power 2 equals 0, of course. Negative half power 2 is 1 over 4 plus y power 2 equals 0, and the solving of this equation is y power 2 is equal negative 1 over 4. Okay. We have here a number 3, a equal x power 2 plus y power 2, and sorry, we have here x power 2 plus y power 2 equal 1. So negative half power 2 plus y power 2 equals 1, not 0. So 1 over 4 plus y power 2 equals 1, and of course y power 2 equals 1 minus 1 over 4, so equal 3 over 4. And also if we take the square root of the two sides, so y equal positive or negative square root 3 over 4, and we have a condition that y greater than 0, so y here will be also 3 over 4, which is positive. Okay, so we have x equal negative half and y equal square root 3 over 4, or we can call it root 3 over 2. Okay, let's keep the results here and turn to another paper. Let's talk again about x and y. We have 2 points. We have a point in the unit circle which is a, and this point is negative half and y, and we have a very important condition that y greater than 0, which is positive. We have here both negative half power 2 plus y power 2 equals 1, because we have a rule that x power 2 plus y power 2 equals 1, or sine power 2 theta plus cosine power 2 theta equals 1. From this equation we have here 1 over 4 plus y power 2 equals 1, and also y power 2 equals 1 minus 1 over 4. So y equal positive or negative square root 3 over 4, and cancel negative because here y is positive only. So okay, so we have positive root 3 over 4, which is root 3 over 2. So we have here again the point will be negative half and root 3 over 2, and we can easily find the trig functions. We know that the first coordinate is cosine theta. Cosine theta here is negative half, and sine theta equals root 3 over 2, and tan theta equals sine over cosine, so it's root 3 over 2 divided by negative half, and we have the result. The reciprocal of cosine is sec theta equal negative 2. The reciprocal of sine is cosec theta equal 2 over root 3, and tan, its reciprocal is cotan theta, which is the reciprocal of this number, which is negative 1 over root 3, because we have tan theta here is negative root 3 over 1. Okay, my dear students, let's take a little break and we return again. Hello again, my dear students. Let's complete our lesson for today, which is trig functions. Let's move directly to another example, and we have a point called A. This point will be on the unit circle here, and this point is negative x and x, and we have a condition also that x greater than 0. That means the x must be positive. We know about x power 2 plus y power 2 equals 1. This is an important rule which we depend on to solve this equation. Negative x is x power 2 here, negative x power 2 plus y here is x. The example that call it x. So y here, we know that any point coordinates will be x and y. So the first coordinate here negative x, and second coordinate, which is y, equals x. X power 2, negative x power 2 plus x power 2 equals 1. So we have here x power 2 plus y power 2 equals 1. Y power 2 is x power 2 now. So we have double x power 2 equals 1. So x power 2 equals half. We divide 2 here. When we take the square root for the two sides here, x power 2, it must be positive or negative half. So x equal positive or negative 1 over root 2. If we put it in the calculator, it will give you it as root 2 over 2. It's the same. This number is the same of this number, but here in simplest form. Okay, and we know the condition that x, it must positive number. So x here will be the positive 1 over root 2. What's x? Here, if we return again to the point A, negative x means negative 1 over root 2. Someone asked me, you told me that x is positive. Yes, x here is positive. X here is positive, but negative is outside the number. So it's negative x, negative 1 over root 2. And y will be x only. So it's 1 over root 2. So we can say that this part, we know it as cosine. Cosine the angle theta here is negative 1 over root 2. And of course it's reciprocal, which is sec theta h negative root 2 over 1 or negative root 2. And also we know that sine theta is this part, which is 1 over root 2. And also the reciprocal of sine is cosec theta, which is root 2 over 1 equals root 2. And we know that tan theta equals sine theta, which is 1 over root 2, divided by cosine theta, which is negative 1 over root 2. So tan theta here is 1. Okay, so cotan theta, it's 1 over itself, because it is the reciprocal of 1, which is 1 also. Okay, sorry, it's negative 1 here, because 1 over 2 over negative 1 over 2, so it's negative 1. And cotan theta, of course, will be negative 1 also, because here negative 1 over 1. Okay, when we find multiplicative inverse of or reciprocal, will be 1 over negative 1, which is negative 1. Okay, let's move to another topic, which is science of the trig functions. What is the sign of trig function? Sign of trig function means negative or positive. Where sine is positive, where sine is negative, and cosine and tan. We here divide x, y coordinate into 4 quadrants. So we have here first quadrant, second quadrant, third quadrant, and finally fourth quadrant. And we know that the first quadrant includes between 0 angle to 90 angle. Okay, it's between 0 and 90. And we have the second quadrant include between 90 and 180 degrees. Okay, and we here know that the third quadrant include between 180 and 270 degrees, and the fourth quadrant of course included between 270 and 360, which is equivalent to 0. Okay, we know about x and y. We know that in the unit circle, if we draw a unit circle here, remember that unit circle, its center is the origin point and its radius is a unit. Unit, as we said, means 1 centimeter or 1 meter. So we have here a unit circle. Its center is the origin point and its radius length equals 1 unit. And if we have a point here, this point will be x and y. Okay, what is x? X is this part from the origin point to B as example, it's x, and this part it's y. If we call this point A, so the point, the line segment AB represents y, and OA is the radius, which is 1, equals 1 unit, because it's unit circle. So as we know, x power 2 plus y power 2 equals 1 from Pythagoras theorem. X power 2 plus y power 2 equals 1 because from Pythagoras theorem, this side power 2 plus this side power 2 equals the hypotenuse power 2. Hypotenuse here is 1, so 1 power 2 equals 1. Okay, we know here that it's xy here, and if we move to this point, which is the reflection of this point on y-axis, here y still positive. Okay, because y-axis starting from 0 here up till there, and this part is up, so it's positive. But x here is negative, so it's negative x. So here is negative x and y. Let's return again to x and y. We know that x here is the cosine theta. If we call this angle theta, x is cosine theta and y is sine theta. So in the first quadrant, x is positive and y is positive. So x, which is cosine theta in the first quadrant, is positive, and y, which is sine theta in the first quadrant, is positive also, and tan theta, which is sine over cosine, which is y over x. Y over x, y is positive and x is positive. Positive divided positive equal positive, so it's positive also. So all trig functions in the first quadrant, we have here first quadrant, all of them are positive because cosine is positive, sine is positive, tan, which is y over x, is positive also. So all of them here will be positive in the first quadrant. And of course, the reciprocal. The reciprocal of cosine will be sec. And if cosine is positive, so its cosec is positive also. Reciprocal of sine is cosec. So cosec also will be positive because sine is positive. And the reciprocal of tan is cotan. And of course, cotan will be positive because its reciprocal, which is tan, is positive. So all trig functions in the first quadrant, which lies between 0 degree and 90 degrees. Between 0 and 90 may be 30 degrees, 50, 60, and so on. So when someone asks us, sine 30, is it positive or negative? We know that 30 lies in the first quadrant. So sine 30 will be positive. What about cosine 60 as example? We know that 60 lies in the first quadrant, and we know that cosine 60 in the first quadrant is positive, so it's positive also. And if he asks us about tan 70 as example, we know 70 in the first quadrant, so it's positive. Okay, let's move to this point here. This point here equals what? We know this is part of y, and y here will be negative because it's down x-axis here, and we know this part is negative, so y here is negative, and x here is negative also because it's left side. We know that ox here is positive, ox dash is negative, so it's negative and negative. So we can say that cosine, the angle which lies in third quadrant, is negative, and of course its reciprocal, which is here is cosine, so it's sec. Here sine theta is negative, and its reciprocal, which is cosec theta, is negative. But here is third quadrant. In third quadrant, tan theta will be negative y over negative x. Negative divided by negative is positive. So in the third quadrant, tan and cotan is positive. Okay, so in third quadrant, cosine is negative, sine is negative, but only tan is positive. Okay, let's move here. First quadrant, sine, cosine, tan are positive. In the third quadrant, which diagonally with the first one, tan only is positive here, but sine and cosine are negative. Let's move to the second quadrant. We know that cosine theta equal negative x, so cosine here is negative, but sine here is positive, and tan of course is negative because tan equal y over negative x, positive over negative will be negative. So in the second quadrant, sine only will be positive because it's y, but cosine is negative and tan is negative also. Let's move to the fourth quadrant. Fourth quadrant here, y is negative, so it's negative y. X is positive, so the point will be x and negative y, which is the reciprocal of and the opposite of this point. This point in the second quadrant is negative x and y, and this point in the fourth quadrant is x and negative y. So here x is cosine, so it's cosine here is positive, and sine is negative, and of course tan will be negative because it's negative y over x. Okay, let's conclude this part, my dear students, because this part is very important for you for studying, because inshallah next year and in third sec will be concerned with this part exactly. So is very important. Let's draw the 4 quadrants again. We have here y-axis and x-axis, x and x dash, and it will be y and y dash here. And as we said, this is the first quadrant, second quadrant, third quadrant, fourth quadrant. We move anti-clockwise direction, okay? And this quadrant, any angle lies between 0 degrees and 90 degrees. This quadrant, with second quadrant, lies between 90 degrees and 180 degrees. The third quadrant lies between 180 and 270. And finally, the fourth angle is an angle lies between 270 and 360. Okay? From our studying now, we have all trig functions here: sine, cosine, tan, sine, theta, cosine, theta, tan, theta. All of them are positive. That means that sine 80, cosine 80, tan 80 are positive. Any number between 0 and 90 will be positive, of course. Here in second quadrant, which lie between 90 and 180, the numbers or degrees between 90 and 180, we can say 91, 100, 120, 130, and so on, 176, 179. All these angles lies in second quadrant, and from the first look, we know that x here is negative, okay, and y is positive. So we know that x is cosine here and y sine. So here sine and its reciprocal is positive. Cosine and tan will be negative. So this part, okay, this part is the kingdom of sine. What's the meaning of kingdom? That's my expression to review or to remind you that this part, which is first and second quadrant, the sign here is positive. Okay, so all of them are positive here. Only sign in the second quadrant, sine 100, sine 120, sine 170 will be positive, but here sine the same, cosine and tan the same angle will be negative. Here we know that x is negative, y is negative also. So all of sine and cosine are negative, but tan is the only function which is positive, because negative by negative equals positive, and sine, cosine here will be negative. This angle is between 180 and 270. We can say that 200, so tan 200 will be positive, sine and cosine 200 will be negative. Let's move to the fourth quadrant. Any angle between 270 degrees and 360 degrees lie in the fourth quadrant. The fourth quadrant here, all of them will be negative, but cosine is the only function will be positive, but sine and tan will be negative. Okay, so if someone asks us, let us about the sign of the function. As example, sine 200 degrees. Where is it? We know that 200 lies between 180 and 270, so it is lie in the third quadrant. Third quadrant, we know that sine is negative here, so sine 200 here is negative, of course, if you ask us about the sign of sine 200. But if someone asks us about cosine to 25 degrees. What is 25 degrees lies? Where? Is it in the first, second, fourth, third, or fourth quadrant? 25 will lie in the first quadrant, and we know the first quadrant, all of the functions will be positive. If one asks us about 10, 310 degrees. If we ask ourselves what is 310, where 310 degree lie, it will be lie in the fourth quadrant. So 10 in the fourth quadrant is negative, so this function will be negative. Someone asked about cosine 7 pi over 3. We know that 7 pi, 7 multiplied pi, which is 180 over 3, and this will be in the simplest form. This is 7 pi over 3, which is 420. If we divide minus 360 from it, one term, it will be 60. So 60 lies in the first quadrant, and of course its cosine will be positive. Okay, and so on. So we now talk about the positive or negative or the sign of the trig functions, and inshallah we are going to complete the next period. Until we meet again, my greetings. My name is Abdalnasser Jabir, and my colleagues in educational one in the Egypt, inshallah. We are going to complete. Goodbye.